Well, good evening, students. It's Mr. Rich. Welcome to the live stream tonight. I'm going to be doing some multiple choice questions for AP Precalc. It's just 2 weeks away for the AP exam. 2 weeks ago, I did some free response questions for AP Precalc, and tonight we're looking at multiple choice. I'm going to try to hit all three of the tested units, starting with Unit 1, and I'll work my way through these, okay, and do a little bit of teaching along the way and try to give you a hand with getting ready for this exam. All right, now, if you are here, you can leave a comment. I will be taking a look at the comments. I'll keep those up. If you have any questions, feel free to post questions in the YouTube chat if that's where you are watching me from, and I'll be happy to answer those. If you see me make a mistake, definitely post something there so I can correct it. All right, so let's dive right in. The first question, I think what I'm going to do, let's go to this view here. Okay. So here's the first question. I've got Desmos open because some of these are going to be done with a calculator, and I'll just give you my spiel on the calculator that you should use for this exam. I'm a big, or at least I used to be a big proponent of the TI-84. I do have a TI-84 here that I could pull up if we needed it. But really, I think that everything that you're going to do on this test, you probably want to do in Desmos, as long as you have some experience using Desmos. If you really haven't used it much, then yeah, stick with the TI-84. But once you get using Desmos, especially the graphing capabilities, then you realize it is so much faster and easier to graph things in Desmos than the TI-84. If you've done any prep for the SAT, then you know how powerful Desmos can be to get answers quickly and accurately using a graphing method. All right, so first question from Unit 1 says that a polynomial function f is given by f of x equals 2x times x plus 1 times x minus 3 over 2. What are all intervals of the solution for which f of x is less than 0? Well, this is definitely a polynomial, and they've done us the favor of giving it to us in factored form. And therefore, I know what the zeros are. So what I'm going to do is I'm going to make my x-axis, and I'm going to plot the zeros. I have a 0 at x equals 0 because of that factor there at 2x. This means I'm going to have a 0 also at -1. And then this means that I'm going to have a 0 at a positive 3, right? If you set that factor equal to 0 and solve for x, you're going to get 3 as the x-intercept. All of these have a multiplicity of 1. That means that when the polynomial gets to this spot on the x-axis, it is going to cut through. I also know that this is a third-degree polynomial with a positive leading coefficient. So from your Algebra 2 class, you should remember that you need to know about what we call end behaviors, and that is that if your degree of your polynomial is even, then the end behaviors are either up to the right down to the left, or excuse me, up to the right and up to the left, right? The end behaviors are either they're going in the same direction. That's if your leading coefficient is positive, but they're going to be going both in the down direction on the ends if your leading coefficient is negative. All right, and in this case, we definitely have this. Well, this is not even, right? This is an odd degree. Our degree here is a third degree. So that means our end behaviors, because our degree is odd for this particular polynomial, the end behaviors are up to the right and down to the left because of the fact that the leading coefficient is positive, right? If you were to multiply this thing and expand it all the way out, you'd have a 2x to the third power, or maybe an x to the third because of this divided by 2 right here. But at any rate, it's going to be up to the left, down, up to the right, down to the left. So I know that what's going to happen is the polynomial is going to be looking like this. Okay, it's going to go like that. So where is it going to be less than 0? It's going to be below the x-axis, right? This means when is the function going to be below the x-axis? Well, over here to the left of -1, and in here in between 0 and 3. And so that is our answer. From -infinity to -1, and then from 0 to 3 is when my function will be below the x-axis. All right. Again, my name is Mr. Rich if you're just joining us, and I am a former high school math teacher. I taught AP Calculus and AP Stats here in Duval County, where I live, and right now I'm a full-time math tutor and coach. Do a lot of high school math as well as ACT and SET prep. Let's go to the second question. This says that the function given by f of x is -1/2 x to the 5th minus 3x squared plus 2. Which of the following correctly describes the end behavior of f? Well, this really is a follow-on to the previous question because I can see that the degree is odd, but it does have a negative leading coefficient. So the end behaviors are up to the left and down to the right. So that means as x goes to infinity, the y values are going to -infinity, and both of these answers have the correct right end behavior. And then as we go out to the left, as x goes to -infinity, the y values are going towards positive infinity. So A is going to be my answer. And again, this is AP Precalc, right? We are doing a review of some multiple choice questions for units 1, 2, and 3 for AP Precalc. If you have any questions for me as we go through these, post them over in the comments section in YouTube. And if you are watching, please let me know. Post something in the comments so I can see that you are here. All right, next question. The graph of the function f has a hole at x equals 2 and a vertical asymptote at x equals -4. Which of the following functions could be f of x? Well, I'm going to do this, right? Before I even look at my answers, I know what's going to happen for me to have a hole at x equals 2. There is going to have to be an x minus 2 factor between the top and bottom, because the way that you get a hole to appear on the graph is you're going to have a factor in the top and bottom that are going to divide out. And I also need to have an x plus 4 down in the denominator. Now, when we look over here and we take a look at this, it looks like everything is in non-factored form. So I do need to factor these. And so let's take a look at D. I'm going to start by factoring the denominator here. So that's going to be an x minus 4, x plus 2. So there's no way that I'm going to get a hole at x equals positive 2 when I have an x plus 2 in the denominator. So we don't like this. I'm going to go up here to A because it looks like that might be what we're looking for here. Could it be x plus 4, x plus 2? I don't think so. And let's see, could this be what we're looking for? X minus 4, x plus 2? No. So over here on this one, if we factor our denominator, I don't think that's going to work. That'd be an x minus 2, x minus 2. Yeah, here we go. I think this is it. This is going to be an x minus, or x plus 4, x minus 2. And if you factor the numerator here, you can see that that's going to be x minus 2 times x minus 2. Therefore, that's going to create a hole at x equals 2. And the x plus 4 factor that remains in the denominator will make that vertical asymptote at x equals -4. All right, moving on. This says the figure here shows the graph of a function p between 0 and 5. Which of the following statements is true about the function of p? Well, it wants to know about the rate of change of p and whether it is positive or negative. Well, the rate of change, right? One of the things we want you to know from Unit 1 is rate of change really is talking about the instantaneous slope. So for example, when you look at this function, if you take just a little slice on the curve, and I'll change my colors here so you can see this. So that right there is a negative slope. The function's decreasing, right? The function's decreasing, so therefore the rates of change are negative. The function is decreasing, so the rate of change is going to be negative, right? It's going to be one of these two answers. It's not going to be A or B. But the other thing that we want you to know about rate of change on a function is whether that rate of change is increasing or decreasing. That has to do with concavity. So in a region where the function is concave up, like this one is, right? Concave up like a cup or concave down like a frown. This is concave up. What that means is the rates of change are increasing if you are in a concave up region of the graph. Now, the reason for that, the reason that that is true is because if you take a look at these slopes, these little slopes here, you'll see that they are actually increasing in slope. So that is a very highly negative slope. This is still negative, but less negative. So you can see as we move left to right, the slopes are becoming less negative. So that would mean like maybe the slope here is -4, maybe -1 about here, maybe -1/2, -1/3. Those are increasing values of slope. So therefore, the rates of change are increasing, even though they are negative, as the rates of change are negative there. Next question. It says the figure shows the graph of a function j in the xy plane with 4 labeled points. It is known that a relative minimum of function j occurs at D. Yep, that's pretty obvious. That's a relative minimum. And the only point of inflection is at C, right here. Of the following points, at which is the rate of change the least? Well, the rates of change have to do with the slopes. Now, one of the things that we know here is that the rates of change are positive here at A. That is a positive rate of change because the function is increasing. The slope of the function right there is positive. Over here, the rate of change is negative because the function is decreasing. But what happens at a point of inflection, this is going to be the steepest part. Now, in this, all the way from this relative max to this relative min, the function is decreasing and the rates of change are negative, but it's going to be at that point of inflection where the rate of change is the most negative. So that means that's where the rate of change would be the least, the highest negative. So the answer here has to be at point C. All right. And again, if you're just joining us, my name is Mr. Rich. I'm in Jacksonville, Florida, and I am a math tutor and coach, former high school math teacher. And we are going over AP Precalc example problems on multiple choice. All right, I see a few of you posting over there in the YouTube chat. Feel free to post a note and let me know that you are here. All right, so Jacko17, can you do some harder ones, please? They're coming, I hope. Well, let's keep going. The rational function g is given by g of x equals this, which the following describes the end behavior of g. Well, the end behaviors of this rational function are going to require me to take a look at the degree between the top and bottom of my rational function. This is a degree of 5 on the top because this is already expanded out. Down in the bottom, this is a degree of 2, 3, 4. So I have a higher degree on the top than on the bottom. Therefore, what is going to happen here with a 3x to the 5th on the top, and it looks like I'm going to have a 1x to the 4th on the bottom, this function is going to behave on the ends as 3x would behave. And how is 3x going to behave? It's going to be going up to the right and down to the left. So that means that as x increases without bound, meaning as I go to the right, the y values should increase without bound. Yeah, so I want A or B because this thing should be going up to the right, because this means as you go right, it goes up. But then as I go left, as x decreases without bound, g of x should also decrease. It should go in the down direction like that. Okay, let's keep it going. The rate, now this one is this is going to be our first calculator active problem. The rate of cars entering a tunnel on a particular day is modeled by the function r, and this is r, where r of t is measured in cars per minute, and t is measured in minutes since midnight. Based on the model, at what value of t does the rate of cars entering the tunnel change from decreasing to increasing? So this is going to be a very straightforward problem. I am going to, we are going to do this in Desmos. I'm going to type r of x equals 0.031 x to the third. Right? I'm going to always be using x as my independent variable on these problems. The only challenge here is making sure that you double and triple check that you are putting things in correctly into Desmos. 1.512. All right, so I think I've got the function in there, 0.31, negative 0.86, 6.324, 1.512. All right, so now we're going to take a look. We're going to zoom out. So you know on a TI-84, you cannot just simply use your middle finger on a mouse and just scroll in and out. So when does the rate of change of cars entering the tunnel change from decreasing to increasing? All right, so the rate of change is decreasing right here, and it looks at this point right here is where it changes from decreasing. The rate changes, the R of t changes from decreasing to increasing. It's going to be this answer right here. So this was nothing more than graphing the function to see when it changed. The rate changes from a decreasing rate to an increasing rate right there. Okay. All right, let's keep going. Now we're heading to unit 2. Two function models, f and g, are constructed to represent the balance of a certain investment account. Both f of t and g of t represent the amount of balance in hundreds of dollars after t weeks for t greater than or equal to 1. Let f of t be this, which is an exponential function, and g of t equals 5 plus 7t, linear function. What's the first time that the amount of balance predicted by the exponential model will be $800 more than the amount of balance predicted by the linear model? Well, what I would do here is I would set up an equation that looks like this. When is f of t predicted by the exponential? When is that? That's my exponential model. When will it be $8,000 more than the g of t? That is the equation that I want to solve, and I want to solve that equation for t. So what I'm going to do here is I'm going to go ahead and graph. And this is basically how I use Desmos to solve an equation here. I'm going to graph the left-hand side of this equation, which is f of t. So I'm going to graph y equals 5e to the x. I'm going to graph the right-hand side, which is y equals 8,000 plus 5 plus 7x. All right. And then what I'm going to do is I'm going to find out where these two intersect. And I know it's going to be way, way up here. I could have changed this to make it a little bit easier, but I just want to go ahead and do it as plainly as possible, graphing both the right and left, finding where they intersect. All right. And that answer that I have is, let's make sure I've got that in there right. When will the what is the first time t that the amount of balance predicted by the exponential model will be 8,000 more than the linear? I've got it in there right, and it looks like this is 7.38482, and it doesn't like that, or I don't see an answer over here that matches this. Okay, and let's see if I've got this in there right. 5e to the x. Yep, we've got that in there. Okay, now for t greater than 1, yeah, so for t greater than 1, what is the first time that it will be greater than? So that should be the number that I was looking for. Let's see, what else? Let's see. Let's come back to this one because I'm not sure. I'm plotting the right-hand side, 8,000 plus 5. And this is represents the amount of balance in hundreds of dollars. Okay, so the problem here is it's in hundreds of dollars. So that would mean that this is supposed to be 800 because $8,000 right here means that it has to be in hundreds of dollars. That's the ticket right there. So that means then we're going to back off of this way out, and we need to go way down here to the new intersection point in here. So when you come in here, yeah, now my did I get the intersection point there? I do have an intersection point, and it is 5.12. And if it's in hundreds, maybe this is, yeah, this needs to be back down to 80, right? Because 8,000 would be 80 hundreds. So now we're coming in to a more reasonable number. Let's take a look here. And there it is, 3.06. Now, honestly, I'm not sure about this. I can say that I can't recall seeing in an AP math class, whether it's AP Precalc or AP Calc, where they kind of make that distinction and kind of trip you up between 8,000 and hundreds of dollars, right? They don't normally mess you up with units like this on those problems, but that's really what it was. This was supposed to be 80, so that 8,000 is 80 hundreds of dollars. Yep. Okay. Thank you. Thank you, Cal Slayer. Yes. Next. Which of the following represents all of the solutions to the inequality that we have right here? Well, I'm going to then go ahead and graph this as well. So I'm going to graph the inequality here. Let's graph the left-hand side here. Now, this one I don't think, though, this one is not going to be, don't think that that one is a calculator active, but we'll come back to that one. Let's try it, though. All right, so if this is not calculator active, what I'm going to be doing is combining these into one natural log function. So that's I'm going to combine by multiplication. So this will be x plus 10 times 5. So this will be the natural log of 5 times x plus 10. And then over here, this will, so this is going to be less than the natural log of 2x plus 17. Now, what I want to find out is when these two are going to intersect. Now, I would exponentiate on both sides. We can drop the log, and we have 5 times x plus 10 is less than 2x plus 17. We'll distribute the 5 less than 2x plus 17. We will subtract the 2x like this, and then we will subtract the 50 over there. So that's going to give us a negative 33. X would have to be less than negative 11. Now, if x is less than negative 11, what that tells me is that there's going to be no solution here, because any number where x is less than negative 11 is going to make this natural log undefined. And the same with this one as well. So the functions really are not even defined there. So we're going to have to go with no solution on this. Okay. All right, let's keep rolling on here. The function f is graphed on the semi-log plot above, where the vertical axis has been logarithmically scaled. Which of the following functions could be a model for f? Well, what they want you to know here is that if you see a linear function on semi-log paper, that this must have come from an exponential decay model. Because if it's a decreasing linear function on semi-log, that means it must have come from an exponential decay. Now, when you take a look at these functions, which ones are exponential decay? Well, this one right here is exponential growth. That itself is a linear function. And so this one right here is going to be an exponential decay model. Now, what does this one look like? 2000 minus 1/2 x. Well, that function right there, right, if you consider it as negative 1/2 to the x plus 2000 right here. So what is that going to be? Well, this would have been exponential decay shifted up by 2000, but there's a minus, so it's actually going to be something that's coming up like this. So we're going to go with C right here for an exponential decay model. Now, one of the things that you can do to check your answer to make sure if you're kind of in between on these two answers is let's take a look at an answer or a point right here. So this tells me that when x is equal to 2, we have plotted the point 100, 200. This is right here is 100, 200, 300, 400, 500. Y is equal to 500. So when you plug this in here, f of 2, you get 2,000 times 1/2 to the second power. And that does give you an answer of 500. Okay, now, if you did that here, that doesn't make any sense, right? This would be 2,000 minus 1/4, and that doesn't give you 500. So just that sort of analysis is all it takes to confirm that that's the answer. These were easy rejects right here, the A and the D, because we did know that that had to be exponential decay. Now, what they're trying to get you to go for is to say, oh yeah, that's a negative, that's a linear function, it must be this. No, on semi-log, they want you to make the connection. That had to have come from a exponential decay function. The other thing that we taught you in Unit 2 was about residual plots, and that if you pick a valid model and run a regression on it, what you expect to see in the residual plot is total randomness. All right, so in this problem, it says that there were a group of students in Mr. Passwater's class. They graphed a set of data consisting of the 6 points shown on the semi-log plot. Vertical axis is logarithmically scaled. Then they used the data to create an exponential regression model. Okay, now that would mean then if they used the data to create an exponential regression and it was linear, then it was the appropriate model. Okay, so that means I am looking for what would be the most random, no pattern residual plot, and that's going to be plot B. Okay, before we move on, just to reset things here, my name is Mr. Rich, and we are doing AP Precalc. If you are just joining us, we're looking at multiple choice questions, both calculator and non-calculator. We are currently in Unit 2 questions, and we'll move into Unit 3 here in just a few minutes. If you are with me, post a note over in the YouTube chat so I can see that you're here. We've got a few people here that have joined us. This says that the function f is given by 4 log 2x minus 3. Which of the following correctly represents the inverse function? Well, we taught you way back in Algebra 2, if not before, to find an inverse function, what you want to do is swap out the x and y variables. So since f of x is representing y, then our first step is to make the equation look like this. And then once you have swapped the variables, you're going to then proceed to solve for y. And once you get done solving for y, then you have obtained your inverse function of f of x. Well, the first thing that I'm going to do here is I am going to add the 3 over, right? Because this minus 3 is not part of the argument of the logarithm. If it were, it would have looked like this. So I'm going to add 3 to the left side, to both sides. Therefore, I get x plus 3. At the same time, I'm going to divide by 4, and that leaves me my logarithm isolated over on the right side. And the next thing that we do is we exponentiate. I'm going to raise 2 power on both sides. That means that those two, an exponential and log of the same base, are going to cancel each other out. It leaves me y, which is my inverse function of f, and then that is going to be my answer, and we're going with that answer right there. Next question. Germanium 68 has a half-life of 271 days. The amount of germanium 68 remaining after d days can be modeled by the function given like this, where A0 is the amount of germanium in the sample at t equals 0. So just your classic exponential decay model right here. Which of the following functions, h, models the amount of germanium-68 remaining after t years, right? So they've changed it from d days to t years, where a0 is the amount at t equals 0. Well, what this tells me here is that if d is in days, that tells me that the half-life is 271 days. Because I'm not going to see the first 1/2. I'm not going to see the first halving of the initial amount until d is equal to 271. On the 271st day, the amount that would be left would be 1/2 of what they started with. That means then that if I'm going to change it to years, then I want the first half to be occurring at 271 over 365 years, right? That right there would be this is the number of years for 271 days. So that means then that that's how many years I want the first halving to occur, which means I really need to be choosing this one right here. Answer C, because if this is how many years the half-life is going to be, when I plug that in for t, that's going to give me an exponent of 1, which will cause the first 1/2 to be applied to the original amount. And here's really kind of the general way that we do this. When you consider an exponential function and you have some initial amount and then you have some decay, that's your base. If I were to just say it's t, and if I let t be years, for example, okay, that would mean that whatever this growth rate is, it's going to be applied. That's going to be the annual rate. For example, if you take a look at an equation that would look like 1 point, let's use exponential growth, okay, and t is in years, that's an 8% annual growth rate. If I decide, though, that I want that growth rate to occur only every so many years, I can change it to t over 5, for example. And that means that it's going to be 8% every 5 years. All right, so that's how you cut back or you extend the amount of time, by dividing by 5. If I were to write this as 5t, then that means it is only going to take 1/5 of a year. This would be an 8% increase every 1/5 of a year, because when t is 1/5, that's when I'm going to get the first 8% increase. All right, let's go to the next problem. Values of some selected terms of a geometric sequence g of n are graphed in the figure above. Which of the following is an expression for the nth term of a geometric sequence? Well, geometric sequences are discrete exponential functions. So you can see that it does take that characteristic exponential shape, but the function itself is only the dots and not the in-betweens. So that's why we call it discrete. It is a discrete exponential. And one of the things that I want to remind you of is that you can write a geometric sequence using the following pattern. You can say the nth term of a geometric is g sub k times the common ratio raised to the n minus k. So you can use as your initial value here any of the terms in the sequence, as long as this k is the term of that sequence. For example, if I wanted to write an equation for this geometric sequence, I could choose to use the number 8 right here and say the nth term is 8. And if I know the common ratio, it looks like the common ratio here is a 2, then I would raise this to the n minus the number of term that this is. This is the 6th term. So I would say n minus 6. I could write it like that. Now, what I'm looking at here, since I know the common ratio is 2, I'm getting rid of A and C. So then I'm looking at, gee, which one of these really is it? So I'm going to look here at the first term because it's n minus 1. So what is that first term? Is it a 4 or is it a 1/4? Right, that's my first term. It's a 1/4. So this has to be an answer of D. If you want to make sure that that's the right answer, let's pick another point up here. This says that when n is 6, I should get an 8. So if we take a look at the sixth term, if I have chosen the right answer, it should be 1/4 times 2 raised to the 6 minus 1 power. 6 minus 1, right? 2 to the 5th power is 32. 32 times 1/4 is 8. So yes, we did get the right one. This gives me, when n is 6, I get an output of 8. All right, let's move on. The table above shows values of an exponential function in the form of f of x equals a times b to the x plus c. Which of the following functions can represent the values? Well, when you have an exponential function that has a vertical shift to it like that does, then what that means is you're not going to see the common ratio right away when you try to ratio these outputs. So if you say 6 divided by 3 is 2, but then 18 divided by 6 is 3. So it doesn't look like there's a common ratio. However, if you look at the first level differences, that's an increase in 3. That is an increase in 12. 66 minus 18, that's an increase in 48. You see what's happening here. And 258 minus 66 is 192. And what you see now, you do see the common ratio. 12 divided by 3 is 4. 48 divided by 12 is 4. So I see a common ratio of 4. The only common ratio, well, this one is the one that I get rid of first because it does not have a base exponential of 4. All right, but it does look like this is going to be shifted up by 2 is what this looks like, because it's 0, 3. Because normally it would be at 0, 1. So it looks like it was shifted up by 2. So I'm kind of liking this answer right here. Let's see if that makes sense. When x is 0, 4 to the 0 is 1 plus 2 gives me 3 out here. Yeah, that's gonna work, because 4 to the 3rd is 64 plus 2 is 66. So we're going for that right there. All right. If you have any questions, let me know. All right, Jacko, if you're still with us, I hope these are hard enough for you. Maybe, maybe not. Here we go. Let x equals natural log of 3 and y equals the natural log of 2. Which of the following expressions is log base 2 of the square root of 12? Well, what I'm going to do is I'm going to, I noticed that I've got 3's and 2's and I got a 12 in here. So I think what I'm going to be doing is rewriting this first as 12 to the 1/2 power. I will then use my properties of logs and call this 1/2 times log base 2 of 12, like that. And then I will break that up into, what should we do? Let's do log of 4 times 3 is 12. That allows me then to break this apart into 1/2 times log of 4, log base 2 of 4, plus log, wow, okay, this is interesting. This is natural log, but yet that's log base 2. That is pretty interesting. Okay, log base 2 of 3 like that. So I can break it apart like this. That's why I have a feeling, I don't know, that kind of looks like that's not. No, I think we can do this. Well, what I'm going to do here is I'm going to go ahead and distribute this, right? This will be 1/2 log base 2 of 2 squared plus 1/2 log base 2 of 3. And this is going to be then bringing that 2 out to the front is going to make that just log base 2 of 2, right? Which is going to be just the number 1. This is going to be 1/2 log base 2. Okay, log base 2 of 3. All right. I kind of like this answer because I see a 1, because this right here is going to be a 1 right there. But then x plus 2y. Then what I'm going to do here, we have to get this in terms of a natural log. So I think then that this would have to be 1/2. We'll do a change of base. So it's going to be the natural log of 3 over the natural log of 2. Aha, pretty clever. Okay, so we have that right there. And the natural log of 3 is an x, and the natural log of 2 is a y. And there is our answer. That is pretty clever. You had to use this change of base right here to get it into natural log. So that means that this is going to be 1 times, again, natural log of 3 is an x, 1 times x on the top, times 2, natural log of 2 is the y. So it is 1 plus x over 2y. A is the answer right there. Okay. All right. Good to hear it. Chaco 17. All right, the next one, let x and y be positive constants. Which of the following is equivalent to this? Well, all of my answers have log base 2. This is just going to be expanding this out. So the first thing that we're going to do is raise this entire thing to the 1/2 power. And we have some options when it comes to our next step, right? I could bring the 1/2 out to the front, or I could apply the 1/2 to the front and then distribute it later. Looking at my answer choices, I think what I'll do is I think I'm going to bring the 1/2 out to the front. And then what's that going to do? That's going to do this. It's going to be 1/2. And now I'm going to split this apart. So this will be 1/2 log of 4 plus 5 log x minus 3 log y. And these are all base 2s. All right, looking over there, I don't really like, they probably want me to go for this, but notice it doesn't have those coefficients. But this right here, log base 2 of 4, is going to be the number 2. Don't forget that when you're simplifying this logarithm, if I rewrite log base 2 of 2 squared, those cancel. So this log right here is actually a 2. So, and then these guys would still remain the same. So if I were to then distribute the 1/2, I would get 1 plus, I would get 1 plus 5 halves. Yeah, it's going to be this one right here. I'll have 1 plus 5 halves log base 2 of x minus 3 halves log base 2 of y. It's going to be this answer right here. All right. Any questions? If so, post them in the chat if you're watching on YouTube. Moving along. Moving into Unit 3. the function, and this is calculator active, the function g is given by 3 sine x minus 3 cosine x and has a period of 2 pi. In order to define the inverse function of g, which of the following is a restricted domain for g and provides a rationale for why function g is invertible on that domain? Well, we're going to go ahead and graph this and take a look at what the function really is. So we will graph this. And what we're going to be looking for is an interval over which it would pass a horizontal line test. Probably the easiest way to say that. Notice that whenever you are working in Desmos, you have this little viewport right here. It'll take you back to the default window, about -10, 10 on each side. Okay, so I'm going to scroll out. Now look, I don't really like what I'm looking at here. So I'm going to come way out, but I'm going to click this wrench and I'm going to really ratchet down on the y's right here. I'm going to go from -5 to 5 so I can look at this thing. Okay, so if you need to scale this thing, you can hit the wrench and you've got your X and Y controls here. Also, keep in mind that when I'm graphing things, I need to be in radians mode. So that really changes everything. So what I'm going to do is I'm going to go back to my home port. So if I go back to my home view, if I had been in radians mode, I would have really been right where I needed to be. When you start Desmos, it's always going to default to radians mode, which for pre-calc is good, right? If you're taking the SAT, maybe it's not so good because you might want to be in degrees, but it will default to radians. Just be aware of that. So then we know that this domain is going to be, needs to be passing a horizontal line test. So what we could do, let's look at these different values here. So this shows you that we go from a -π/4 and we come up here to a 3π/4. I think this is going to be it. Okay, I've got two answers with π/4 and 3π/4. The function does pass a horizontal line test, so therefore over that domain, it would be invertible. Now, about the -π, I'm not sure exactly where that's going to be. So I really don't like either of these answers at all. But what's the right reason? Because this interval has a half period, or because all possible values of g of x occur without repeating? Yeah, the y values are occurring without repeating on the interval, passing the horizontal line test. So my answer here is going to be B, right, like that. And again, this is the beauty of Desmos, right? You don't want to answer this question on the TI-84. It's going to take a lot longer to graph, and you can't just simply click to find these relative extremes. Right, you've got to punch about 8 buttons to find those relative extreme values, and they're not going to be put in terms of pi like they are in Desmos. So I can't emphasize enough that if you have not been learning Desmos this year, you still have 2 weeks to get some practice in so you can use it on your test. Now, how many complete cycles will this function have on the interval 0 to 2 pi? Still a calculator active. We're going to graph this thing. -13 sine of 4 pi x. Okay, there it is. I'm going to rescale it. And boy, that makes me wonder, did I put it in right? Well, I got to put a 13 in, not a 12. I'm not sure that matters too much, but there it is. It says, now, how many complete cycles will it have? Well, what I'm going to do is I'm going to zoom in here and find out. I'm not even sure that I want to do this on Desmos. Right. So I want to look at how long the period is. So one thing I know is I can just simply kind of look here at what the distance is between these two relative maxes, and I'm looking at the distance. Are those looking at the right ones there? That looks like they're crossed up, but it looks like it's a 0.5 is the difference there if I subtract those two x's. So it looks like the period is 0.5. Now, this is 2 pi. So how many cycles will it go through? It'd be going over 2 pi over 0.5. If the period is, if that's how wide the period is, and you're talking about that many radians, then it would have to be it'd have to occur 4 pi between 0 and 2 pi. Okay, so that's going to be my answer there. This is a calculator active. It says the function g is defined by this, just your typical parent function for sine with the constants there. In the xy plane, the points 4, 12, and 8, -2 represent a maximum and the next minimum value, respectively, on the graph of g. What could be the values of a and b? Well, a is the amplitude. So therefore, I kind of know what the a is going to be because I am going to find out the distance between the y values, which is 14, and I'm going to divide that by 2. So a could be 7 or -7. Okay, so I'm going to go with that because the amplitude would be 1/2 of that distance between the two y values on the max and the min. All right, now what about the period? Well, let's take a look at just a typical sine function here. You know, how you have to take a look at how much of a period is it between a max and the next minimum. That's only half of a period right there. So therefore, what that means is they've given us the x values. That means that 8 minus 4 units. 4 units. That means the period has to be 8. So the period has to be 8 units. And therefore, this b is 2 pi over 8, which is pi over 4. Remember, that's your coefficient here in front of the x in your standard form there for sine. It's 2 pi divided by the period. So I used this distance 4, doubled it to get the entire period, and now I know A has got to be my answer. Okay. All right, 17. Let's see how many more we've got here. We are almost to the end. The figure shows the graph of the polar function where f of theta is 2 cosine theta minus 1 in the polar coordinate system, 0 to 2 pi. There are 5 points, A, B, C, D. I see them in E. If the domain is restricted to pi to 3 pi over 2, which following statements correctly describes the portion of the polar graph in the domain? Well, what I'm going to do here is I'm going to find out where the function is, what the r value is for those two extremes. So I'm going to come to my function here and say, what's f of pi? That would be 2 cosine pi minus 1, right? Cosine of pi is going to be -1. So that would be, right? Cosine of pi is a -1. So that'd be -3. And then where is what is 3 pi over 2? So that would be 2 cosine 3 pi over 2 minus 1. Cosine of 3 pi over 2 is 0. So that's going to be a -1. So let's plot those 2 points. When I'm at pi pointing in this direction, it would be -3. So I'd be over here at point E. And then at 3 pi over 2, 3 pi over 2, that would be pointing down, but yet the value is -1, so I would be up here. So it looks like I am in the first quadrant and I am traversing the distance from E to D. There's really no other option there, I don't believe, that you could. So this really tells the whole story. Now, if you are doing one of these problems and it's a little bit ambiguous as to which path you took, perhaps, then what you can always do is do an in-between. Like, for example, I could then, if I wanted to, say, gee, what's f of 5 pi over 4? Or let's do a better one than that. Let's do 4 pi over 3. That's 2 times cosine of 4 pi over 3 minus 1. Well, cosine 4 pi over 3 is a -1/2. So that would be a 0. That be right? Cosine 4 pi over 3 is a -1/2. No, that gives me a -2. Because it'd be 2 times -1/2, which is -2. So 4 pi over 3 would mean I would be pointing in this direction, but yet I would be at a -2. So I would be somewhere up here in the first quadrant. So that kind of confirms that, we've got the right answer here. Well, we've got time for one more. Let's see. I think we should do a trig. Let's see. Are both these trig equations? Yeah. Let's go ahead and solve this one. This wants me to solve for all values of x between 0 and 2 pi. And what I'm going to do here is do a Pythagorean substitution here. For cosine squared, I am going to put 1 minus sine squared x equals sine x plus 1. We'll distribute the 2. And it looks like I'm going to be solving this by factoring. So I'm going to leave 0 on the left, move this over to the right, plus sine x. And then when I subtract the 2 to the other side, it's going to give me a -1. So it looks like I'm going to be able to factor this as the product of two binomials as though it were a quadratic. And that means I need to put a -1 and a +1 right here. And of course, that's sine x, not x. Okay, because now I checked my FOIL here. My outer product is a +2 sine x. My inner product is a negative sine x. Those combine to be a positive sine x, so I've got it right. I'm going to split these into two separate equations. All right, so I'll set that equal to 0, which means sine x would be a half. Where is sine x a half within my unit circle? That's going to be at pi over 6. And then again over at 5 pi over 6. Here I get sine x is equal to -1, and that's going to be equal to -1 when x is 3 pi over 2, like that. Okay, what do we have in terms of answers here? Yeah, it looks like D is going to be our answer. We've got these three solutions. Okay, everybody. Well, it is 8 o'clock here, and that is all the time that we have for tonight. I hope this week and the 2 weeks prior were helpful to you. Next Sunday night, I'm going to be doing an AP Calc review at the same time, 7 o'clock here on YouTube. So check me out there. And if there's anything I can do for you, drop me a note. I'll put my contact information up here as we leave. Thank you again for attending. If you're watching this by video on YouTube, drop me a note. Let me know you watched it. Otherwise, everybody, have a wonderful night and a good week ahead. Bye. And good luck on that AP exam.